Dear students, once again very warm welcome to your online classes, and I hope you all are well and studying in your home also. So in the chapter of water, we already discussed about the physical and chemical properties of water. Today we will talk about how water acts as a solution. So today is your topic, solutions as mixture of solids and water. So first of all, you have to know that what is a solution. A homogeneous mixture of two or more substances whose relative amount may be changed with certain limits is called a solution. To understand this, solution is a wide term and includes homogeneous mixture of substances existing in any physical state. Thus, we can have solid, liquid, gas, or solid, liquid, etc. types of solutions. Okay, homogeneous mixture means any mixture which have the same proportions of its components by given any sample. When there is any sample, the proportions of the components whatever found in this as solid or liquid or this any stage, they have the same proportions. That's why it is called homogeneous mixture. You already read about this in your earlier classes. So water is a solvent and it is a universal solvent because it dissolves a large number of solutes. The solution of different types of solids in water are quite common. However, some other solvents such as alcohol, benzene, petrol, etc. are also used for the preparation of certain specific type of solutions. So in this chapter, whatever theory things you can easily learn that what a solvent, solvent. Okay, so in solute and solvent, first you have to know that what is a solute. The solid substances which get dissolves or disappear in the liquid solvent to form a solution is called solute. It means which dissolve in water. Okay, the substance which mainly dissolve in any solvent. So solvent, the liquid, water or any other medium which allows the solute to dissolve it in order to form a homogeneous mixture is called a solvent. For example, when common salt is added to water and the mixture is stirred well, common salt disappears and a homogeneous mixture called solution of common salt is in water is obtained. In this case, a common salt is the solute and water is the solvent. So this is the example. You can see common salt example. You already learned in earlier classes also. Okay. Dilute and concentrated solution. Dilute means the solution in which the amount of solute is relatively small as compared to the amount of solvent present in a given mass of it. It means when there is more number of solvent is present in any solution is called dilute solution, or concentrated, the solution in which the amount of solute is relatively larger. Okay, vice versa, you can say in dilute solution the amount of solute is less, and in concentrated solution the amount of solute is higher than the solvent. In case of liquid solution, the liquid has lesser amount is called solute. Okay, these are easy things, so you can also read one time. If you have any confusion, then you can ask. Unsaturated, saturated and supersaturated solutions. Unsaturated solution is said to be an unsaturated solution at a particular temperature if it can dissolve more of the solute at the same temperature. Okay, unsaturated means when any solution is dissolve more of the solute at the same temperature. Okay, for example, by example you can understand more better. At 20 degrees centigrade, 100 gram of water can dissolve a maximum of 36 gram of sodium chloride. Therefore, any solution containing an amount of less than 30 gram of sodium chloride in 100 gram of water at 20 degrees centigrade is unsaturated because it can dissolve more of the sodium chloride at the same temperature. Okay, now is saturated solution. A solution is said to be a saturated solution at a particular temperature if no more of solute can dissolve in it at the same temperature. Suppose we have a saturated solution of sodium chloride at room temperature 25 degrees centigrade. If some salt is added to it and the same temperature and the solution stirred vigorously, the added salt will not dissolve and will get settled at the bottom of the container. So you can see here, no more solute can be dissolved at the same temperature in a saturated solution. Okay, a normal example I can give. Suppose this is a beaker you have and you this much amount of water you have. Okay, this much of amount of water you have and you fill sugar in it. Okay, so then the sugar which is comprised in this space, it can dissolve, but when we put more and more and more solution more solute of sugar, it cannot dissolve. So that's why it is called a saturated solution. And super saturated solution, a solution is said to be super saturated at a particular temperature if it holds more of the same solute than that of required to be present in a saturated solution at the same temperature. It's just vice versa of saturated solution. Okay, concentration of solution. How can you calculate the concentration of solution? Percent by mass upon mass in terms of percentage. Mass of solute into 100 upon mass of solution. When you have to calculate percent volume upon volume, volume of solute into 100 upon volume of solution, and percent mass upon volume, mass of solute into 100 upon volume of solution. So for example, a solution is 65% by 65% mass upon mass. Okay, you have to relate this is the example I relate this. Okay, 100 gram solution, 60 gram of solute, and in volume upon volume, 100 ml solute, 65 gram of solute, and in mass upon volume, 65% by volume upon volume, that is 100. Sorry, this is the mass upon volume. Okay, last given volume upon volume. 100 ml solution has 65 ml solute. So mass of solution always equals to mass of solvent, and volume of solution is equal to volume of solute plus volume of solution. Use of specific gravity. Specific gravity term is used for density in case of solution. When we said about the density of any solution, it means specific gravity. The term density refers to the ratio of mass upon volume for pure solvent. Density, weight of solvent upon volume of solvent. Examples: 50 gram of glucose is present in 200 gram of water. What is percent mass by mass? So you have to calculate this. So mass of solute is 50 gram given. Mass of solution, what happen now? Mass of solute plus mass of solution. 50 plus 200 is 250 gram. So now you calculate easily. Mass upon mass percent is 50 upon 250 into 100, that is 20%. And if another example is given here, 2.5 ml alcohol and 7.5 ml water are mixed to give a solution. What is volume upon volume percent of solution? Here you have to calculate volume upon volume percent of solution. So volume of alcohol is 2.5 ml, then the volume of solution, what happen? It will become volume of water plus volume of alcohol, that is 10 ml. Now we have to calculate easily. 2.5 upon 10 into 100, that is 25%. Okay, so you have to learn this formula of concentration of solution. If in exam asked, you can easily calculate them. Okay, some notes. Whenever these notes are given to your book, you have to read them and understand. Benzene is used for rubber as a solvent. Carbon disulfide is used for sulfur and phosphorus as solvent. Turpentine oil used for paints and paraffin wax as solvent. You already heard about it. Petrol is used for greasy material as solvent. And some other also notes given here, so you read them. Now we move to the solubility. What is solubility? Okay, the solubility of a solute in a particular solvent at a particular temperature is the maximum amount of solute dissolved in 100 gram of solvent to form saturated solution at that temperature. Okay, so you can say easily that the amount of solute dissolved in 100 gram of the solvent to form a saturated solution at the particular temperature. You have to read for remember in mind, and whenever this term is given, it means it's a occur in a fixed temperature. Okay, the solubility of solid is usually expressed as the mass of the solute in grams dissolved per 100 grams of the solute. It may also expressed as gram liter minus 1. Okay, so how can you determine the solubility of a solute? So prepare a saturated solution of given solute at 25 degrees centigrade as reported earlier. Now take out little amount of this solution in pre-weight small beaker. Now again weight this beaker containing solution. Now heat the beaker gently to dryness so that all the water evaporates off. Cool it and then fill again the beaker with solute. Okay, so this is an experiment you have to do. So mass of empty beaker you have to first note down, then mass of beaker plus solution is called as M2G, and mass of beaker plus solute is M3G. Now the mass of solute is equal to M3 minus M1. Okay, so you have to minus from here, and mass of solvent M2 minus M3 gram. Now your solubility easily calculate M3 minus M1 upon M2 minus M3 into 100. You have given examples also. 160 gram of saturated solution at 25 degrees centigrade of a solute can evaporate to dryness, leads to 10 grams of solute. What is solubility of water at 25 degrees centigrade? So your solution is here. Mass of solution is given 160 gram, mass of solute is 10 gram, and mass of solvent is 150 gram. When you calculate it, you have to just do minus. Okay, then solubility is mass of solute upon mass of solvent into 100. So 10 upon 150 into 100. Okay, because 10 gram is evaporates, you have to remember, then we will do minus here. Okay, 150, right. There are some factors which affect the solubility of solid in a liquid. Nature of the solute and solvent, temperature also. Okay, these are simple terms, you have to read them and learn them. Now we move to the solubility curves. The effect of temperature on the solubility of a solute can conventionally be expressed in the form of a curve called solubility curve. It means you just remember that whenever we talk about the solubility curve, it means the effect of temperature on the solubility of any solute. Okay, the solubility curve of some solutes are shown in figure 3.9. So you can see one example I will give you, and you have to understand others. Okay, calcium sulfate. The solubility curve of calcium sulfate, I'm just giving this example because you have to understand that how to understand the figure given for any type of situation. So calcium sulfate, the solubility curve of calcium sulfate shows a slight upward trend up to 40 degrees centigrade and then register a decline. This clearly indicates the solubility of calcium sulfate increase slightly in going from 0 to 40 degrees centigrade and then decreases on further rise in temperature. So you can see from the figure that from 0 to 40 degrees centigrade, CSO4 is here. Okay, as we go from, this is the solubility gram per water, and these are the temperature given in, okay, there, x-axis. So you can see here it increased till 40. Okay, see here, temperature given till 40 it increases maximum. Okay, then it will decline slightly. One more example we take potassium nitrate. Okay, so potassium nitrate, you can see till where it will goes. Okay, it records a sharp upward trend with rise in temperature. This shows that the solubility of potassium increases sharply with rise in temperature. Okay, as temperature is rise, its solubility also increase. So you have to understand this, like, and in sodium chloride, okay, in sodium chloride it's a moderate, the solubility curve of sodium chloride almost parallel. Okay, it means solubility of sodium chloride increases only a little with rising temperature. It may be regarded as fairly independent of temperature. So you can say that this, in the solubility of NaCl there is no effect of temperature. Okay, like this you can also evaluated other compounds also. So from your home you have to read the importance of these solubility curves and some question answers of very short answer you have to start also. So we will meet in the next classes. Thank you.